Okay, so lesson 1.7 is actually the last lesson in the topic. Remember, topics are chapters, just a new word for it this year. So with this being our last section, we're actually going to probably spend the most time in it. And I have a quiz written over just this section and sent to the printer, but I have not decided if I'm going to give it or not. It's just going to depend on how it goes. If we're feeling really confident with it, if we're feeling ready for the test, I will not assign that quiz. We'll just take the test. But if it's a concept that we definitely need more, more structure, more feedback on, then I have the quiz and we'll take it. I don't want it to sound like a punishment. It's not. It's just at this point, we need to see how it goes. So if we can take these notes down together and we take that quiz, that's where you'll use these. Okay? Otherwise, tests. Are you allowed notes on tests? No, it'd be a note card though, and all your note cards can be made from your notes. So lesson 1.7 is writing a proof. So it's our first introduction into that. It's a very, very big topic for advanced geometry students. A proof simply proves an argument or a conjecture. So maybe I should use that word because that's kind of one of our new vocab words. A conjecture. So it proves a conjecture true, ideally. That's what we will do. There are some proofs that will prove things false, but we won't get into that yet. The student that was with us from Simpson yesterday is in geometry class at college right now, so if you have any interest in knowing what that looks like, you could always talk with her when she comes back. All right, so what I want you to do is just start with an example, because I think if you were to see it, it'll all kind of make sense. Okay, so based off of our begin at Bell, you're going to be given something that's just an algebra equation. That's what you're going to start with. It is going to be your job to solve that, providing reasons the entire way through. The reasons are not things I'm going to ask you to memorize. Rather, they're things you're just going to be able to access. So this blue sheet is as important as anything I've passed out this year. You need to keep this, it's blue for a reason, in the front of your notebooks if you have a folder for that. This is accessible to you on all tests. So note cards and this get to go with you for any work that you do. I will continue to hand out, hopefully blue paper doesn't disappear by the end of the year, but each chapter will get a new sheet of blue paper that you'll just staple to it. And then by the end of the year, you'll have 10 different staples in your packet, but hopefully you'll have 10 sheets that go with the topics we've covered. So everybody have one in this group? Okay, so if I can get you to look in this section called Properties of Equality, this is where we're gonna start. This is how our proofwriting process begins. In your groups, really quickly, I want you just to, and this is kind of individual at first, but I want you just to go ahead and read through this column, and as a group, identify the ones you know, the ones you're comfortable with, the ones that make sense to you, and the ones that you haven't seen before. Ready, set, go. Easier place to start once you've read them. So maybe talk about the ones you haven't seen before after you've read them through. Which ones seem new to you today? You heard all before? That's one you haven't heard before. Which use words reflexive, symmetric, transitive? Have you heard those words before? Oh, good. Okay. Okay, you've seen how those things look before.
So you just have to write.
Okay, so.
Okay.
For proofs,
Yeah.
it's not an English reason.
Yeah, you're exactly right. You're headed in the right direction. So 2 groups told me division property was new to them. Anybody else give me a property they haven't seen before? I was expecting these bottom ones to be new to you. Reflexive, symmetric, transitive, substitution, probably not, I guess. But have you seen or heard those words prior to this experience today? Something? We'll continue to use them, but this is your reason category for all your algebraic proofs. Every proof that we write today is going to have a reason from here. And it's as basic as it sounds. The addition property of equality allows you to do what to both sides of the equal sign? Add. So the subtraction property of equality allows you to do what to both sides? Subtract. And then so on and so forth. Multiplication the same way. Division, the new one, that works the same way. It allows you to divide each side of the equal sign by the same value without changing the equal sign. All right, are we good? We're alive? We're healthy? We're making this work? Let's see it in action, and I'll give you some of your own. Hang in there with me. So go back here. Key elements to writing a proof. I actually do give credit for this because it is that important. 2-column proofs will be the way that we work every single proof this year. You'll see other types, but you'll be required to just be assessed over this type. You need to have the word statements and the word reasons positioned as such. Make sure the statements is always on the left and the reasons always on the right. Okay. Now, the other thing that I actually give, so this is called just how you set things up. The other thing that's also required every single time is that you set up with a given. So giving me just this hardware that I call it is worth credit. Partial credit, teeny amounts of credit, but credit. This is required on every proof you write. No matter what, this will all be there. Okay, the rest of it, that's where it gets a little bit different every question you do. So the first thing we do is we think about what we've been given. And in this case, it's -5 equals 3n plus 1. Now the statements are what you did for the begin at Bell. The statements, that's old hat. It's the reasons that we'll focus on. Reasons can come from 3 places. Reasons can come from definitions. Reasons can come from properties, which is what you just looked at. Theorems and postulates. Those are the only places that reasons can populate from. You'll notice that on this blue sheet that I passed out to you, it has theorems and postulates and properties on it. The only thing not on the blue sheet is the definitions, and those are required just to be kind of memorized. Any ones we don't feel like we can memorize, we can write down on the blue sheet, okay? All right, so properties, theorems, and postulates. I'm going to highlight them in blue because that's where they come from. Let's start with our first step on the statement side. Turn and tell your groups really quickly how you would solve this. What would you do second? Okay, do not actually write the -1, but I heard it from everybody that I could hear. Don't actually write the -1, you just write the end value. So if I subtracted 1 from both sides, I'd have -6 equals 3n. The reason for that has to be a definition, property, theorem, or postulate. And I told you they will come from the property list today. Which property did we just apply?
Subtraction.
You got it. Subtraction. So you are welcome to do a couple of things. SUBT is just fine. This is also just fine. And then property of equality, we kind of took the shortcut of doing POE last year. And I'm okay with that. You are required to have property of equality there because eventually you'll have different properties. So eventually it'll be property of congruency as well, and you have to distinguish between that. All right. So far, so good questions. Anybody have anything for me? Okay, keep going. Telling your groups what you do next to solve this one, please. And then do it, but don't show it. Do it, but don't show it. And the reason you don't have to show it is because you're writing it. You're telling me. Which property should I apply?
Division.
You got it, division. So I'm a huge fan of just using symbols. I don't mind words, but symbols are fine. Division, property of equality. All right, now this is picky, but it's a good one to practice with. I would rather have what first, my variable or my constant? My variable. Is there a property that allows me to switch them so that the variable does come first? Do we all agree with Josh? Symmetric, let's take a look at it. If A equals B, then B equals A. Does that fit exactly what we need to do?
Yes.
You got it, good. So you knew you could do it before. You knew you could switch them without any penalty. Now you know why. So the symmetric, you're just gonna have to shorthand symmetric, property of equality. All right, so that's your first proof. Not too bad. We usually like algebraic proofs.